This is a headline you don't want to see. I think you as developer, nor your business or your boss. This is what really happened in 2002 when Jeff Bezos got hacked by WhatsApp. Not on iOS or on the other OS feature, just by a vulnerability in the app itself. Every feature or even bug you have in your app could be a vulnerability for somebody else. So what could be a really nice feature like a password reset function or something else could be used maliciously by somebody else. Or even a user, because if a user can gain something from your app, it will do so. So take care of your features and your bugs is, of course, the thing. For example, the 7-Eleven one, they made a password reset functionality, which was really great because you could fill in, if you clicked once, you could fill in any email address in the world, and it will reset the password for that account on your email address, which is, of course, really a handy feature if you want to gain access to somebody else's account. Another way that mostly brands, but also, of course, apps get exposed or not in a good daylight is by copycat apps or fake apps, which are originally just a copy of your app with the same functionality, but they added some extra functionality for their own. Or it's an app that looks the same, but doesn't do the same. And, for example, wants to give you a fake subscription for a lot of money per month instead of your functionality you have. What they try to do, of course, is to make money themselves or get data so they can sell that on the black market or even on the normal internet. Let's see, where was I? Sorry. Oh yeah. So what they do is they will take your app and then add, for example, advertisements to it or malicious code to get, for example, more permissions, for example, for your contact list, and try to read that out and send that to their own server so they can exploit that for their own gains. Most people think that only is used in jailbreaked or rooted mobile devices, but most of those tricks will happen, more than 50% of those tricks can be exploited with a normal application without any root or any other means in the application itself. I think the best example for this is the Fortnite one. Fortnite, of course, a popular game, did announce their own application, a mobile application, and then the application itself was just a launcher which downloaded their own app. So everyone faked that one, put it in the App Store, and downloaded their own application with all the malicious code in it and other intents as well. Even till today, because Fortnite, of course, is banned from the iOS App Store, there is a lot of fake applications who tend to, or pretend to be Fortnite so that people download them and, of course, get that code on that device. You would say most apps that are fake would be, won't go through the review process we all know or hate eventually. But that's not the case. Most apps will definitely get through by any means, so they try multiple times, they change different things. So every day there are like thousands of fake applications which people download and think it's your app. Besides that, there is a whole world beside the App Store with other app stores, like Chinese, of course, is one example, but also in Europe and the US, that are app stores that deliver applications that were cracked, for example, because they are paid on the App Store, but in that App Store it isn't. So people sideload those applications on their device and, of course, get exposed with more advertisement or malicious code in that way. Another trick that is current, or not that current, but is gaining momentum is the supply chain attacks. Most people think know from last year. And with those supply chain attacks, what they try to do is attack your tools, so the tools of the developer. So that can be the IDE, that can be plugins you use, it can be dependencies, of course. And the main target usually is not the developer, although that helps, because developers have, like, for example, access tokens or different kind of access to systems which they can gain access to and also exploit. But mainly it is the goal is to get into your app, because you use that tool or that dependency for your application. So they tend to try to get into that and then exploit it when it's on the device of the user. This is, like I said, gaining momentum because an average software project these days has 203 dependencies external, so that's a lot. I think React, of course, has some more, but still. So you need to look into that as well, like if they are secure. I think the best example here is British Airways. They use the Modernizer library, which most people know from web development, which just is there to detect functions if the browser does or does not have that function. What the attacker did is add some little code to that library, which got included in the checkout page of every British Airways website they have. And then every input that was made on that form was sent to their own server. And of course, that was also the credit card number and the CVS and the expiring date. So that was not great. Also, the app didn't use Modernizer in the same way, but it was included. So all the input from the app was also sent to their server. And thus, there are like 300,000 people who were hacked in that way with false claims, of course, of credit card details. And British Airways last year was fined, I think, $20 million, of course, of that, because they didn't do the right thing and didn't have the proper security rules in check as well. So what can we do about those things? Well, of course, know your service. So React, of course, React Native has multiple services. This is the mobile part, because of course we have Windows and Mac as well, or even tvOS or whatever. So, but know what the code does, understand it, and maybe also try to be creative how you can misuse it. If, for example, you don't know that much about Android or iOS, please take somebody in or hire somebody or contract somebody to get that knowledge in-house, or get that knowledge about what everything in your app does and how it can be, not misused in any way possible. Of course, the other way is documentation. Of course, that's obvious. Katie, who couldn't be here, unfortunately, has done a really great job about the security chapter on the React Native documentation side, so definitely read that. Also, Google and Apple have good guidelines about security, what to do and what not to do, what to take care of and what not to take care of. So please read those carefully. A really good shout out to Julia. Julia's from Kazakh Labs in Ukraine. She already is doing talks about this topic, about React Native security, and I think a few years now, addressing most of the pain points it has, like dependencies and other things, like the service is, of course, greater. And she is also part of the OWASP group, and she has done some really great blogs about it as well. So everything to take into account if you create a React app and you do, for example, cryptography in your React Native application. As mentioned, OWASP is mostly known, of course, for the web part, but they also have a mobile security section in their site. They even have a top 10. It's the same as, or it is not the same, but the same thing as the web part. So there are 10 vulnerabilities or ways to be vulnerable that they think are the most important. It's not up to date anymore because I think it's from 2017 or something, but it's still valid because I think most of those who are in this category are definitely needed to be checked if you make an application. They also have, OWASP also has the mobile app security requirement and verification project, which is a mouthful. And what that is it's in essence a checklist, and it's a few Excels, which can be filled in by not only the developer, but also business and some other people who are entwined in the app, or for the app and the app business. So to check if you have take every measurement or not. If not, it will print out a score and even a web about which points you can improve or you need to take a look at. It's something all my clients use to build their app and verify if we think it's safe to get it out in the open. The other one we talked about already is know your dependencies. So by knowing your dependencies, I mean really know them in that sense, like not only doing an npm or yarn and then install it and because I saw the GitHub. No, know what it does. And like most clients I work with, we audit every dependency there is. So that means we know what the code does, we know what the service is, what they tend to do or not. And in this way, of course, you never have surprises. But of course, the downside is that in every update, you need to check what is changed or what isn't changed, of course. And of course, use tooling for most of those things. Of course, for dependency, like I said, know your dependencies more like you knowing them. Of course, there is Dependapods, who most people already encountered, I guess. Or Sneak, which is the same thing as scanning your dependencies and see if there's a vulnerability, which is great. Also, there are penetration tests you can do for free. There is the Mobile Security Framework, which is an open source framework, which tests your app in multiple ways and tries to see if there are vulnerabilities in it or yes or no. So you can get a really nice feedback on what's best or not. And of course, you try to solve them as well. There's also a commercial version from Immunio app, which uses machine learning to do the same thing. They have a whole suite about getting you secure. And of course, there's, for example, ESLint can help you with, for example, tedious input or something else. So make rules for things that could be a security or some leak or some parts you need to look after or look at. So I wanted to show how easy it is to tamper with your app. So I made an application, just an easy, just React, not an Expo one, but just a React Native init for an app. And what I've done is I have added the jailmonkey dependency, which is made by Gant Labor from Infiltrate, which only detects if a device is rooted or jailbreaked, yes or no. That's the only thing that it does. So my code in React is really simple. By default, of course, it's not jailed, and if it's jailed, then it will say so and put out another image. That's all the app does at this point. I compiled those. So those are in here. I compiled those in an APK and an IPA, which is, of course, for Android and for iOS. So first, let's look at the iOS one. Those IPAs and APKs are just archives. That's it. So it's nothing fancy or encrypted or whatever. Those are plain, if you got them from the device, mainly. I won't show you that. And it will extract all the assets and the application itself to the folder you mentioned. So what I have here is the, let's bring it up a notch. So I have the app, as you can say, just called an app, just so it's app.app, which is also a directory with all executables in it, but also the assets. the images we just talked about, and the bundle which Metro created for us. So if we install that, let's do that. And we run it, then it should say it's a jailed device because the simulator is by default jailed. I don't even know if you can jailbreak a simulator. I guess you can't. So it's a jailed device. So OK, then you would say, OK, how can we tamper with it? Well, we can take a look at the bundle, which is a compiled or a bundled JS file, which is run, of course, by React Native. So if we look like, OK, we used a function here, which is jailbroken, and we take a look at it, like, OK, where is it? Now, here is the function called, and this is the logic I wrote in myself. It's like, if it's jailbroken, say this, and otherwise, say the other part. So it's jailed. So, OK, that's not what I was looking for. If I look at this one, this is more interesting. This is the code from the dependency I got from jailmonkey itself. So what I could say is, OK, but what if I just return true always? So not making any other comparison, just saying, OK, this is true. And then let's install it again, because I don't need to recompile whatever, because it's a resource file. And then click on it, and voila, it says it's a jailbroken simulator, which doesn't exist. So in your bundle, there is a lot of code which is just exposed. All the dependencies are in there as well. So you could definitely just change it, recompile, which I won't show you, but you can recompile the app just in a zip format, sign it with your own signature if you have one from Apple, and then just send it away to the App Store, for example, for reviewing, which hopefully gets rejected because it's not your app. So it's really easy to do that. You might think, well, maybe I have it in native code, which is better, maybe, because it's more not obfuscated, but more difficult to read, which is true, but we have tools, and one of them is, for iOS, is I don't have a license at the moment, no, which is Hopper, which does read and disassemble the app. So if I open the app, yeah, it's just x65, so it will load. And this is all compiled code, so it's difficult to read, of course. That's the obvious case with all compiled code, but it's not with iOS, but also on Android, it's not impossible to read. So if I take a look at the jailbreak, it's now loading, still loading, then we see this function, which is made in Objective-C code by the jailmonkey library. We can see, OK, this has an address, so it's called. So let's see where it leads. Not using the structure, but I need the function itself. And then we see here is the function, which is, for example, the jailbroken message, which is giving the message back to the bridge, which gives back my true or false in the app. And if I look at that, I go to the, let's see, better in graph mode, I guess. I have a graph, as you can see. It's a true-false statement, as you can see. There are some other statements if you look in the overview. But in essence, it's the same thing. So if you, I think it was this one, if you change that hex code or assembly code to the false flag, and you recompile it back to an app, which I can do because it's a demo version, you have the same thing, it's returning always true instead of getting that comparison. So then, of course, you can do the same trick, package it again, send it to the App Store or a different store, and people can download it. So it's relatively easy to modify if you know what you're looking for, and that's what the internet is for. Or if you do it like this, you can even inject your own advertisement framework, for example, and give advertisements in the app, although you don't have advertisement in your app. No, I don't save. Well, and on Android, it's the same thing. Other tools, of course. So we have JDEX. Start it up. which will give you, on this side, it will give you all the classes you maybe know from Java as well. And it will, if I look at my app, it will be there, like app. And of course, in the resources, the bundle is there as well, in the assets folder set. So here's the bundle, which is the same bundle as the iOS one, because of course React Native is on both. And I can make those changes here again as well, or extract it, make those changes again, package it again, and send it to the App Store again. So it's the same thing. What also is interesting, the app has some, most people use it, of course, is environment variables. So if I have an environment variable, for my Google Maps key, which is a really bad idea to do it, by the way, in here. Let's rephrase that. Don't do this. But if it's in here, this is not a nice place to put it for some people. But if you do that, it will get compiled in the code. But I can really easily look it up. Let's see. Let's search for it. Oh. And here it is. So it's the same key in plain text, and you can rip it out of the app and use it anywhere you want, which is, of course, not ideal. That's why, of course, Google also has the server-side protection on it, and hopefully you have too. So as you can see, it's really easy to do it in this way as well. So Android isn't better or less better than iOS on this point. So everything you put in the app, you can, by any means, and of course, with effort, you can take it out again. The last thing we have in the app is code push, or with Expo, of course, we have the AS update these days. So we going to, let's see, I think it's in the app. Yeah, it's an update, and it just says I want to update, and then eventually I will get the update. So what we can do is we can look at the traffic that is going in and out of the application. So what I'm going to do, and it already has one time looked up like, I'm here. So if I click on the button, which is a button, it will say there's an update. So you can see there's a network request going out, like, okay, this is the update. This is nice. There's a download URL. That's nice. So if I click install, it should download, if the network is present, yes, it should download the app, update, and put it in there. Great. But what if I could change that direction of that URL? Because if I downloaded the URL myself, I did that already, of course, it is just, also, it is just a zip file. I have it here. It is just a zip file, this code push file, or this file, which I downloaded, is just a zip file which contains the bundle, because this one is a really easy app, we don't have multiple bundles, etc. And it has asset files, which are the same files as you know. So if I change those, put that into that zip file, and I would put it somewhere else and do a man-in-the-middle attack by redirecting it to my own URL, then of course they get my app. So let's do that. So what I need to do is first get the app off my simulator, because it already has the update. So I will install it again. I will change where it goes to, and I will go, of course, I will let it redirect to myself, because that's the easiest way. But there are multiple ways to do it, of course. Then I will serve that file. And if everything goes correct, we have this one. And if I click on it, you get an update from somebody else. So yeah. So I'm Wouter. Please keep your app secure. Until next time.